One line in a spectrum shouldn't exist. This one didn't blink, it got louder. James Webb saw the wrong kind of life signature. Right-handed amino acids, the mirror of our biology. The press release said noise, but one inverted peak refused to disappear. Stay with me. By the end, you'll see why the "just a comet" story doesn't hold. One peak, wrong hand, no easy way out. In 2025, an interstellar stranger dipped into our sky. Astronomers tagged it 3I/Atlas, a cold nomad from somewhere beyond our sun's influence. It brightened as it fell inward, tails unfurling, cameras clicking from mountaintops and deserts. The official tale was clean. Sunlight heats a fragile body, ices boil off, stress fractures spread, and the comet shatters into dust and vapor. Beautiful, poetic, and familiar. The light show fades, the data is archived, and the world moves on. Case closed. Or that's what the public got. Months later, when the spectacle had long faded, a routine sweep began. James Webb tilted toward the faint debris cloud that still traced Atlas's path. Deep in the infrared haze, a whisper appeared. Weak, wavering, easy to dismiss. Analysts shrugged. Sensors breathe, backgrounds drift, cosmic clutter fakes patterns if you let it. But one analyst didn't move on. They circled a line that shouldn't exist in any comet. Biology is handed. This signal picked the other hand. To see why that matters, think about chirality, handedness. Your hands look the same, but they don't overlap. Life on Earth made that kind of choice long ago. Proteins use left-handed amino acids. DNA and RNA use right-handed sugars. That uniform choice, Homochirality, is one of life's signatures because random chemistry mixes both hands. Life picks one and defends it. Our enzymes, the locks of our cells, only turn with the right keys. Flip the key and it doesn't fit. Not automatically poison, but often invisible, often disruptive. So when a spectrum hints at a dominant right-handed signal, our mirror image, that isn't just unexpected. In our context, it's forbidden. Meteorites have shown faint imbalances before, but a coherent, persistent bias in the wrong direction hints at something else, an ecosystem that took the other fork. So far, one rogue peak, a life-only bias, and dust that shouldn't be biased. The team tried to kill the anomaly. Background subtraction, calibration checks, cross-correlation with known lines, synthetic controls, different pipelines, different assumptions. Each filter stripped away excuses. The spike persisted. Not loud, not flashy, but steady. An inverted chiral tell hiding where randomness should reign. A whisper hardening into a voice. Now the human part begins. A handful of analysts see the same pattern and reach the same uneasy thought. Late-night calls replace live chatter. Private threads replace open channels. One camp pushes, publish everything, this could be history. The other camp cautions, false alarms burn trust, and if it's real, it's a biohazard we don't understand. The institution splits between two instincts, tell the truth now or protect the world from a truth that might not be ready. Publicly, nothing changes. A comet broke up, end of story. In this scenario, the rest moves behind higher clearances. Jets don't steer, unless someone's steering. Rewind the footage with new eyes. Those outgassing plumes on the sunlit face weren't perfectly random. Some erupted at angles that nudged the body. Tiny, precise changes stack over time. The math showed a small push the gravity models couldn't explain. Asymmetrical outgassing works as an answer. Or, seen through this new lens, those jets behave like control thrusters, trimming course the way a pilot taps a joystick. What if the breakup wasn't failure, but delivery? The official explanation fits the playbook. Thermal stress, volatile ices, structural weakness, then boom, fragmentation. But a timed failure can look like a planned release. Fragments fly apart, Dust blossoms into a diffuse halo and the cargo spreads. What looked like collapse might have been the moment of delivery. You don't need metal to make a carrier. Ice, dust, and chemistry can do it over eons with intention hiding inside physics. If that's true, the stakes aren't cinematic, they're chemical. The debris doesn't leave overnight. It threads the inner system, Earth's orbit, Mars's path, the asteroid belt. Particles graze atmospheres, settle on rock, embed in ice. Most die under radiation, oxygen, and time, but not all dust lands in hostile places. Some slides into shadows, brine pockets beneath salt crusts, microfractures in polar ice, sheltered pores in basalt. If mirror life exists and remains viable, it wouldn't merge with us. It would ignore us. We'd be ghosts to each other. Our food isn't its food. Our pathogens aren't its pathogens. Its enzymes speak a language our bodies can't parse. That mismatch could be protective or destabilizing, depending on where and how it wakes. Reality check. Detecting chirality remotely is brutally hard. Even a cutting-edge telescope is stretching to see such a thing. An inverted spectral signature would demand multiple instruments, independent teams, and open replication before anyone should make a claim. That's why this is a thought experiment, an exploration of what we'd do if chemistry sent a message we couldn't explain away.
So far, an inverted peak that won't die, jets that look like nudges, and a breakup that reads like release. Now zoom in on the analyst. You rerun the pipeline 10 different ways. You ask a colleague to try on their end. The peak comes back like a heartbeat. You submit your summary. A polite thank you arrives. Then silence. No preprint, no seminar invite, just a quiet handoff upward. You walk home under a normal sky, feeling like something fundamental shifted and only a few people noticed. If the signature is a message, what language does it use? Not words, not radio. Chemistry. In a universe ruled by physical law, chirality is a choice life makes once and then defends. A right-handed biosphere packaged into an interstellar carrier is a calling card. It says we exist, we evolve differently, and we can cross the dark. It could be an invitation. It could be a warning. It could be a proof of concept flung into the void to see who listens. Delivery windows aren't always doors. Sometimes they're breakups. What do you do with an ambiguous, high-stakes signal? Reveal it and risk panic, speculation, and fakes? Or hold it back and risk the slow erosion of trust and the perception of a cover-up when the story leaks anyway? Real science crawls forward through replication, peer review, and open data after safety is understood. Real safety demands caution before disclosure. Those priorities can collide. People inside institutions have to choose which wound is worse: uncertainty's sting or secrecy's cut. Let's walk the map. If mirror life can persist, Earth is hostile but not hopeless. Sunlight, oxygen, and a busy biosphere shred most travelers quickly. The safe niches are cold, dark, and patient. Deep subsurface brines, salt-protected films, ice-capped lakes, cave systems sealed from the surface. Mars may offer similar refuges: ice tucked under regolith, salty seeps that flicker on crater rims. Farther out, the icy moons become prime arenas. Europa and Enceladus vent oceans into space. Fallback snow returns it to the surface. A dust grain carrying mirror chemistry could ride a plume and settle into a fracture where time runs slow and reactions run deep. None of this guarantees life, only places where a seed, if real, could hold on. What actually happened with 3I ATLS? The safe answer is still the simplest. A fragile interstellar comet heated up and came apart. Every step of that story has precedent. And yet, unrelated facts sometimes start to rhyme. A chiral hint where randomness should rule. Jets that look less like flukes and more like nudges. A breakup that under a different light resembles a scheduled release. Each piece alone is explainable. Together, they make a pattern you can't unsee. Jets don't steer unless someone's steering. Maybe this is just an elegant ghost in the data, the kind that haunts anyone who stares too long at too little signal. Or maybe it's the first brushstroke of a larger picture. Directed panspermia, executed not with antennas and rockets, but with ice and time. If you can't share a language, you share a law. Chemistry becomes the alphabet. A mirror biosignature says in the most universal terms available, there is another way to be alive. If a discovery like this ever becomes real, the first steps won't be dramatic. They will be careful. Independent teams will try to reproduce the signal. Different instruments will revisit the target. Archived data will be remined for corroboration. Lab work will stress test how chirality imprints on spectra under space-like conditions. Only after multiple lines converge would any bold claim see daylight. That's how good science earns trust. What if a comet wasn't a comet? What if the jets were thrusters and the breakup was delivery? What if a faint, inverted peak is the most consequential whisper we've heard? What would it mean to coexist with the biosphere that doesn't recognize us and that we can't touch without breaking? Is it a threat, a treasure, or a mirror that shows us our limits? Look up tonight. The stars don't change for us, but our understanding does. Somewhere, the rules of life took a different turn. If a fragment of that story drifted through our neighborhood and shed a chemical signature in its wake, the real question isn't whether we're ready for the answer. It's whether we'll recognize the message in time to reply. Tell me where you stand. Was it mirror or noise? And if the universe ever speaks in molecules, will we know how to listen?